Hi everyone, welcome to Introduction to Geometry Vocabulary. Please make sure you copy these definitions down. The first one is a point, a specific place in space or a location. Points are typically denoted by a capital letter, so I'm going to draw a point right here and I'm going to call it capital A. Always a capital letter for a specific point. The next one is a line. A line is a collection of points. And that kind of makes sense if you think about it. A line is a collection of points because if I had a bunch of points in a row and I connected them, then they would make a line. Lines typically have arrows in both directions and there could be points on top of them. So if I label this AB, I would have an A here and a B here, and it would be signified by line AB. Notice the arrows that are on top of them. The next one, array, is a collection of points that has one endpoint and extends forever infinitely in the opposite direction. And that would be denoted by, let's say, 2 points here. We'll call it C, D, and E. And this would be ray CE with an arrow going that way. The next one is a line segment. A line segment must have two endpoints. So we'll do RS, and it would look like this, RS with a little line segment on top. Notice for a second, this is important, that in this case, when I have a line, we have arrows on the tops, but over here when I have a line segment, I don't. And then over here, when I have a ray, I only have one arrow. So keep in mind that that becomes important later in the year. The next one, a midpoint, a segment that divides, a point that divides the segment into two equal parts. So what I'm going to do is write this as RS, and I'm going to make this point right in the middle. It'll be M, and a midpoint cuts a segment into two equal parts. So I'm going to make that equal to that. So in this case, let's say that this was 5, this would be 5. I would know that those would each be equal, and the entire line would be equal to 10. The next one, a segment bisector, a line or a segment that cuts through the midpoint of another segment. So I'm going to draw this, and we'll make it RS again, and we'll have the M in the middle. And now I have a line that goes through this, and it'll look something like this. I'm going to make a line, very thin, and it could be like that. Now this segment bisector is just cutting these two pieces into equal parts. The next thing, collinear. Collinear is talking about specific points that are on the same line. So I might have something like A, B, and C. And if I'm able to draw a line that connects the 3 points together, then they would be collinear. Now, if I was to put point D over here, that would not be collinear because I'm not allowed to draw a line that goes like that. That would be not collinear. Which brings us to our next definition, non-collinear. So non-collinear, points that do not lie on the same line. So we'll call this A, B, and C. A, B, and C are collinear, but point S is not on the same line. So that's not collinear. Let's take a look at the next page. On the back, we start with the first one. A plane is a one-dimensional flat surface that extends forever in all directions. Typically, planes are drawn like this, and you will typically have a letter that represents the plane. So your desk or the floor are examples of planes. Coplanar is items that lie in the same plane. Keep in mind that if we had points, we could make a plane, and there might be in a three-dimensional object different planes So those would be non-coplanar. The next one is segment bisector. Sorry about this, kids. Notice it says C number 6. So we did that one already. Perpendicular lines, lines that intersect to form right angles. So if I have a perpendicular line, it's going to look like this. I'm going to make a right angle. The symbol is an upside down T, so it looks like this. And it'll say something like AB is perpendicular to CD, and you would label this AB, CD, and perpendicular with the right angle. The next one, parallel lines. We pretty much know this already, but parallel lines are two lines that extend forever and never touch. And the symbol for that would be a single arrow. If we had multiple sets of parallel lines, we would go to double arrows or triple arrows. The next thing, a regular polygon. Regular polygons are kind of interesting. They could be squares, or they could even be equilateral triangles, or we could even have a pentagon. I'm not going to try to draw that, but you get the idea. And then the last thing is a circle. So a circle is a polygon with no sides. It's a collection of points equidistant from the center. So if I wanted to make a circle, something like that, and the point in the center, which I will call it center O, all the points around the circle are equidistant to that center O, and that's what makes a circle. Thanks everybody, and I'll see you soon. Bye.